for a while. So Anson Sando, I know him very well. I mean, we worked together on few things. And in fact, yesterday, Anson took a lot of people around IIT Madras Research Park on a tour. He does a lot of work in energy efficiency for IIT Madras Research Park. Sanjay has been with L&T for a long time. Now he's on his own doing some excellent management stuff. Anandnambi works with Technip. He'll tell us a lot more about what he does. Startup Singam, Arun was earlier here. Arul Shanmugasundaram, well, he presents a very interesting portfolio. When I first contacted him about 10 days, 20 days back, he was with Ayana. He was in a very senior position. And now he is in a far more senior position with Swelect. He has just become the CEO of Swelect Energy. Folks, welcome, and Tina, please take over. Thank you.
So here, welcome to this panel discussion of the intersection of energy efficiency and digital and AI solutions. I'm Tina Philip. I'm a director with Accenture Ventures. At Accenture Ventures, we partner with and invest in B2B technology startups. And I've had the pleasure of working with several sustainability startups as part of a program that we've been doing with IIMA Ventures called the Sustainability Value Accelerator. And we've also invested in a deep tech startup in the area of space tech, actually, Pixel, which again has got use cases in the area of climate tech. So very happy to be here and moderate this panel discussion on energy efficiency. So I think you've all heard different perspectives about energy efficiency so far. And I think it was Mr. Bansal of Blue Ashwa who said that 90% of the investments right now in climate tech is going into renewable energy. So when we talk about climate action, I think that's the first thing that comes to everybody's mind. It is around renewable energy. And perhaps energy efficiency is considered perhaps the less glamorous side. But as we heard, this is a commercially viable option right now, and hence something ripe for the startups to innovate in and for the investors to invest in. Because, in a way, if you think about it, the cleanest energy is the energy that one doesn't even use. And that's where energy efficiency comes in, right? And when you look at the untapped potential in this market when it comes to energy efficiency, I think of late digital and AI solutions, I'm sort of clubbing both of them because AI is part of digital. There's a lot of things happening in this, So because I want to make it broader into digital because we're talking about data coming in from sensors. We're talking about digital twins. We're thinking of predictive analytics and maintenance and building algorithms specifically for chillers, blasters, etc., which can all help with energy efficiency. So as part of this panel, as you can see, I have a very distinguished panel with me who will be ready to provide diverse perspectives, from renewable energy to the intersection of academia, investors, and startups, and of course from the digital and AI side as well. So thank you so much, Arun, Dr. Arul, Anandnambi, Anson and Sanjay for making it here today. And I know Narsi said wrap it up quickly because we are already running late, but I have 5 great people here with me, so I definitely want to hear from them. So we're going to anchor this discussion around 3 key things. One is, what's the state of energy efficiency currently in India? What are we doing? Where are the gaps? How can digital and AI solutions help? And what's the role that the different ecosystem players can play? Whether it's investors or startups or the industry, academia, etc. So that's where we are going to kind of base our discussion on today. But before we get into the discussion, I'd request our distinguished panelists to introduce themselves very briefly as per Narsi. So briefly about you, your role, your company, and one line about how you are related to either energy or digital and AI. So Sanjay, would you like to kick off?
Yeah, good evening all. So I am Sanjay. I am founder CEO of Orbit2 Next. And this company was just formed in November 24, okay, just recently. And we are primarily into 4 different verticals. The first one is strategy and intelligence. So we are doing a lot of assignments for GTM strategy. We are doing assignments for risk management. We are building strategies for a company which wants to invest around $2 billion in India. And we are preparing for them the review of the processes, operation efficiency, a lot of things are happening on strategy and intelligence part, right? We are also doing some exercises on DTV, that is design to value and value engineering. And this is primarily to reduce the BOM of the renewable projects, right? So we are doing that. And we are also working on digital twinning, right? Digital twins. But we are still building that capability. So we'll be happy to collaborate with anybody here who is really having the strength of digital twins, because we have got few assignments which are actually requiring digital twins. And the second vertical is primarily on project management, which is with project management as a service or project management consultancy. And we are trying to build up a co-pilot model also. And third, of course, is renewable EPC, hardcore EPC, engineering, procurement, construction. And the fourth is people orbit, which is primarily getting into skilling and getting into connecting campus to corporates, trying to have embedded talent solution. This also we have at least made the frameworks. Probably next 2 3 months we'll be on the ground, right? And thank you for here, and happy to be here. Right.
Thank you, Sanjay. Anson?
Great. Thank you, Renasi and Tina, for sort of welcoming us and having us here. I'm Anson, and I head the energy programs here at IIT Madras Research Park. Just a little bit about what we've done here. Over the course of the last 3 years, I think around 2022, we've embarked on this sort of journey towards 100% renewable. And what we wanted to do different or sort of unique in this campus and help make this a demonstration of sorts is try and make this not only 100% renewable, but also match it real time 24/7. And that's a piece that I think is often overlooked. And part of the ways through which we've done that is actually through energy efficiency and looking at it from a very holistic perspective. So we not only have solar and wind that's meeting the generation requirements of this campus, but we've also built, designed our own energy storage systems. And then to sort of manage the whole piece and to ensure energy efficiency, we've also developed an energy management system that sort of controls and operates all of the energy that we're actually consuming in this campus today. So I think there's a lot of work that we've demonstrated, but the idea has simply been to showcase its economic viability. And I'm happy to share some numbers over the course of the session today, but just to give you some rough sort of ballpark figures, we're saving 35% of our electricity bills as compared to what we were paying 3 years back. So there is definitively now a use case, not only from a carbon perspective, but from also a cost perspective, which I think is going to be very integral as we sort of talk about this whole energy efficiency. But thank you again, and looking forward to the session.
Thank you, Anson. Anand?
Thanks for the opportunity. I'm Anandnambi, and I'm responsible for digital innovation for India Operating Center in Technip Energies. I think a lot of you may know Technip Energies as a big EPC player, but we also have complementary business models where we are also technology provider. We do licensing, we do PMC, we also are critical equipment manufacturers. We have a modular manufacturing yard in India. And there is also another business model that we are already doing in terms of digital and AI. So we not only develop products that will improve our project delivery, but also platforms for the clients and the whole ecosystem. Just to highlight, we do have our in-house carbon assessment platform. We have digital twin energy system frameworks, which we offer as a services to big clients and as well as public sector companies.
Thank you. Dr. Arul?
Hello, yeah. Hi, so my name is Arul. So I think I've recently taken up as MD and CEO of Swelect Energy Systems, and Swelect does EPC. It also has IPP assets and rooftop systems, and also manufacturing. Right. So my experience, obviously, I think Anson talked about it. In fact, today we had 100 megawatt round the clock power in my previous role for a large metal company. And today we are just starting the run. I think our solar, wind assets and battery assets are all ready to go. So certainly we were able to provide a very attractive cost, I think, for the customer. And of course, we are still not what he's talking about, meeting the entire demand, because we didn't have the flexibility of tailoring the demand to the generation on renewables. But we are definitely able to meet 85% above PLF on a yearly basis with purely renewables, and also at least 50% in every 15-minute time slot. I think that's something we believe we can achieve, and I think the test is starting today for that. Of course, it's going to be a long process, but certainly I'd like to talk about the software and the other AI aspects of the requirements to be able to do it successfully.
Thank you, Dr. Arul. And Arun?
Hello. Thanks, Tina. My name is Arun Nair. I am the CEO of Startup Singam. And I think I'm the only one who's sitting in this entire line who has not got nothing to do with the energy sector. So we run a televised platform for fundraising for startups. We are sector agnostic that way, and have been a part of the Indian startup ecosystem for last 10 to 12 years. So have been able to work with some of the startups in all across the spaces. So happy to share some of the stories in due course of this talk.
Thank you, Arun. So as you heard, quite an experienced panel that we have here today. So I'd actually like to start with Dr. Arul, because Dr. you've been in the renewable energy space for a while now, and a lot of experience there. What I wanted to ask you is, I think India has set some very steep targets when it comes to non-fossil fuel-based energy by 2030. And we are making progress, I would say, steady, but maybe not rapid. Wanted to hear from you, where do you see digital and AI solutions kind of playing in this renewable value chain? Could be solar, could be wind, could be something else. But how can digital and AI solutions really help in the renewable value chain? And the reason why I ask is, of course, there are entrepreneurs sitting here, and they would want to know what are the gaps that the industry is seeing right now. So if you may.
Sure. See, I think the one thing I would say is, look, energy, today I think the solar energy is in excess in the hours we are generating, and if you follow the exchange markets today, you can buy it at 1 rupee also in some time slots. I think last month with the monsoons being good, I think we had 1 rupee time slots also, right? And so is wind. Wind is also. So I think what you're dealing with is two infirm sources of energy, which can be developed very fast. You can put a solar plant in a year, you can generate a lot of energy very, very quickly. But then the country or the requirement is not limited to those particular slots only. You need the requirement of 24/7. And of course, we are more a service economy than a manufacturing economy. So certainly our night consumption is less, but we still have the challenge of 7 to 10 or 6 to 10, where the demand is very high, and the costs of power also, if you were to value the power in real time for that time of the day, it's quite high, right? So when you're talking about these energy, commodity energy like solar and wind, and now, so now if you're talking about the growth, so for example, you talked about 500 gigawatt, it's not going to be able to absorb 500 gigawatt of pure vanilla solar or wind anymore in the grid. The grid cannot do it, right? So what is required is, how do I take this energy from solar and wind and convert it into a 24/7 round-the-clock renewable power? And I think that's where the challenge comes and the value proposition comes. And I think I think a lot of digital and AI obviously have a very critical role. And of course, the first holy grail of the whole thing is forecasting. how do I forecast my solar or wind or sun or wind irradiations and wind projections? And of course, wind is, I thought solar was bad, but in the last 4 years of dealing with wind, it is, it's, I don't know what to call it, but it's much more temperamental than solar, and even a 15-minute projection is quite difficult, right? So I think the first start obviously is, can I project, can I forecast solar and wind? And certainly AI, ML is sort of a good approach to forecast. In fact, I've made this attempt twice with the very Microsoft, honestly, with the Microsoft research at Redmond and globally. 2 times I made this attempt to do a AI, ML model of projections of, we just did solar, we didn't even go to wind. Wind is of course a much more complex situation, right? And one of the interesting things what I've learned is, like, when you take AI, ML and you take the data, you give the data and it tries to fit a curve, right? And of course that's a simplistic view of my statement, but obviously over parameterization happens with the data you give. And unfortunately the noise does not remain the same from one set of days to another set of days, or one location to another location. So that over parameterization sometimes leads to surprising results when you go into a different set of circumstances. So my first experience is, yes, we need to do something here, but a pure AI ML model, I'm not sure is going to cut it. There has to be some physics in the model. There has to be some noise handling, and not no over parameterization. I think that's the first thing where I think AI ML can play a role, but I think it needs to have some physics. It cannot be a pure digital model because of the noise levels and the unpredictable nature of the noise. Right? The second area is, like, of course, once you predict it, I know what I'm going to, like today, one of the things we were working on it in my previous role is you have a 24-hour projection, right? So based on the forecast 24 hours ahead, I have to project it, right? Then I need to figure out, when do I pump power into the battery and when do I take it from the battery to match the demand, right? And in my case, I was looking for a flat, because I am talking about a large smelter which is 24/7, so my demand is not changing much. Right, so we also have a major project with railways, but that is still probably a year away in my previous role. When to come to fruition, there of course the demand, there is a variation, but in the smelter's case it's a flat demand. Right? How do I take this energy and use it in a smart way to maximize the coverage across the day? I think that's another challenge where I think we have used AI ML algorithms. Of course, a lot of people use the multi-integer linear programming to solve for it, but it's also not such a straightforward a case of, I would say, a closed form equation where the results are definite, right? There is always a variability and a robustness issue. So I think overall, I think if you are taking energy, which is a commodity, and if you have a good algorithm, you have a good solution, you can make money. Obviously, you buy power at a lower cost and sell it at a higher cost. That arbitrage on the time of the day, when you are buying power and when you are selling power, and the intelligence you build into it, right? How do you monetize that? That's a second question, right? That's not so trivial. How do you monetize this? Of course, you can offer it as a service, but I think in India, people will not pay for it. They'll say, why have to pay for it? And the earnings will be minimal. The real value is, how do you buy energy and sell energy? If you are able to do that and do that smartly, I think that's where the big value proposition is. But that may not be possible for everyone to get into an exchange role. But I think there's definitely a huge opportunity for algorithms, and there is an opportunity to monetize them also.
Thank you, Dr. Arul. So I think Dr. Arul has thrown out some problem statements for the startups out here, something which even the Microsoft researchers were not perhaps able to do. So if there are innovative startups here, entrepreneurs who are thinking about these problem statements, then please do reach out to Dr. Arul. I'd now like to go to Sanjay, actually. So Sanjay, Dr. Arul spoke about the renewable energy industry itself. I want to talk to you more about some of the harder to abate industries like construction, manufacturing, where do you really see digital or AI solutions coming in with respect to energy efficiency in these industries? Because these are not traditionally industries that are willing to change much. So how do you kind of build in these digital and AI solutions in such industries?
Yeah, I'll try to give some examples of manufacturing and projects as well as construction industry. But before getting into it, I'd like to come to one statistics that is called energy intensity. Probably everybody must have heard of it. It is quite simple equation. The energy consumed by the country divided by the GDP, right? So if you see India today, right, so last 20 years, the energy intensity has dropped by 40%. So saying that energy efficiency has not happened is actually not correct, right? So a lot of exercise has happened by people sitting here as well as people sitting outside this room, right? So a lot of things have happened. And if you compare this, of course, from $4.2 trillion economy, we are trying to move quickly towards $5 trillion, right? But if you compare us with US and China, if you see, is more manufacturing intensive and they've got a lot of industries. So their energy intensity, if you see, is at least 1.5x of ours. But we are, if you see our energy intensity, it is 3 times of US, right? Predominantly because they are more service-oriented economy, right? So they are at $30 trillion and they are more on service side, right? So everybody has contributed for it, right? So it is not exactly that it is all because of energy efficiencies. There are other parameters also. I'm not getting into the inflation aspects and other aspects. I'm trying to keep the equation very simple. Now to start with the efficiency in, let's say, start with projects, right? In project, we solved a simple problem, right? And today morning, if you see Professor Ashok Junjunwala, right? He was telling that a lot of problems, it doesn't require a complicated equation, right? You really do not require LLM to solve all problems, right? It is not possible. So there was a very simple problem statement where we were trying to reduce the tonnage of module mounting structures, right? So module mounting structures is the structure where the modules, you must have seen those on the rooftops here, right? So if you say that, if that is given to multiple discipline people, right? So what happens is, if you give it to an electrical engineer, he will always try to optimize the maximum energy out of it, right? And if you give it to the civil engineer, he will try to bring the wind load because of this guy, right? Because of the civil engineer. And when you put this into a larger equation and put it in your financial model, you will find that even sacrificing a little bit of tilt and sacrificing a little bit of generation will reduce a lot of capex, right? So with that capex, our team had developed a simple equation and they had run that on a macro equation. And then they found that, yes, they can easily reduce around 2 tons per megawatt, right? So 2 tons per megawatt, if you look at the scale, what we were, the assignment for whom we were working at, they were looking at portfolio of 5 gigawatt. So you can see straight away, 10,000 metric tons have been saved, right? And as Tina was started research, has said that whatever saved is actually generated, right? So, and getting into that much of steel, actually we saved. So if you see, for every ton of steel, right, the energy required in terms of crude oil equivalent, for every kg of steel, you require half kg of crude oil, right? And that is only for the crude steel. And beyond crude steel, you need again to process that for usage in the renewables. Then you will have the other aspects as mining, and you will have the logistics part. So if you look at the total quantum, you look at the amount which has been saved. If everybody is adopting it, let's say on the same equation, and looking at 2030, probably we want to inch around, I think 250 gigawatt more is to be installed, right? If Arul, if I'm correct on that numbers. So 250 gigawatt multiplied by 2 tons, 2,000 tons per gigawatt. You look at the volume which has been saved, right? And so much of energy is saved. Now if you see energy again, a steel industry, 90% of energy is coal. Only 10% is electricity. So when you're talking about energy, most of the people actually relate that to electricity. It is not so. Electricity is just 17% of the total energy. So when you're talking about energy efficiency, it has to be a bit holistic when you're looking at each component, and probably you have to look into the whole value chain. So this, in the projects, we did that exercise, and it has really turned with the simple equations and a simple solution. Now coming to the manufacturing part. So we were doing one exercise. Means an investor wanted to invest in a company. The ticket size was large. It was around $600 million he wanted to invest. So we did the process mapping. We tried to see whether implementing Industry 4.0 or any tweaking, understanding the risks, understanding the workflow, where are we able to really reduce the cost, right? So reduce the cost by increasing the efficiency of the whole plant, right? So that also we were confident that yes, that exercise is still on. So around 2.5% is the targets what we have set internally, 2.5% of the revenues, right? That's the target we have set internally to achieve by adopting all these IoT measures, digitalization, even the ERP integration, all these will happen, right? And coming to the larger brick and mortar business, which is construction, as Tina was saying, nobody is willing to change. But there also we got a simple, it looks a simple problem. So in Chennai, if you see the metro rail, they have deployed 21 tunnel boring machines. Means there are 21 caterpillars running under the soil. We do not know how many. And each consumes around 8 to 15 megawatt of energy, each tunnel boring machine. And along with the tunnel boring machine, there is a lot of muck removal happens. So there is a lot of requirement of excavators, trucks. Then there will be round trips, efficiency of that, what should be the sizing of that. And then the conveyor belts, which is going to carry the muck to a point of exit overground, right? So there are a lot of such things. But this particular problem cannot be solved by putting sensors everywhere. It's not possible, right? So that's the reason they said, can we do this with digital twins? Can we prepare some information based on all of these equipments and try to create a model on digital twin and see whether, by doing a lot of simulations, whether that is really working, right? And the target given are like morning also, if you see Ashok was talking, Dr. Ashok, Ashok, he was talking about setting aggressive targets, right? So the targets what has been set is saving entire energy. Energy is not limited to electricity. Energy involves all the diesel, which is getting into all these vehicles, number of vehicles, even looking at the value chain, the construction equipment when it is coming from somewhere, manufacturing. So all that energy which is required, can we reduce that by at least 10 to 12%, right? So it cannot happen with what you call the conventional methods. Probably a lot of AI, a lot of digital methods, a lot of digital twinning may have to happen, right? And I think I have covered the most crude sector, and people say it is really, a lot of people call that as dirty job, but I think that is one of the best jobs I have been doing so far, right? Thank you.
Wonderful, Sanjay. So I think you've touched upon some of the very hard industries, and even there, the value that actually exists in such initiatives. So on that note, I'd like to go to Anandnambi, because you're kind of on the other side. You know, you are implementing digital and AI solutions for your clients. And we've been hearing, I think, you know, slightly, I would say, contradicting views, where an earlier panelist was kind of talking about, you know, that the plant managers, they don't really care, you know, whether we do energy efficiency or not. They just want to run their shift and go. Whereas for the CFO and the CEO, maybe it is a concern. So when you are looking at implementing digital and AI solutions for these, especially energy intensive industries, what are some of the barriers that you come across? And, you know, is it cost? Is it capability, or is it culture? And how is Technip thinking of, you know, kind of overcoming these barriers to actually implement these digital and AI solutions?
Okay, so I think you have already mentioned the list of all the challenges. Even within our company, when we wanted to, you know, make sure that all of our employees during our project execution implement the digital tools and AI. So there we find that, okay, people are, let's say, culturally speaking, they're used to their own mindsets in terms of how things work, and that's more prevalent in our industries as well. Whereas, especially in the process industries, you know, we lack we lack today, let's say, data models and information models, because we are still relying on our old methods of, let's say, traditional equations, fitting the curve, and then going back, do some experimental studies, and then coming back and finding a solution. So why not we do, let's say, because what we are trying to, in the end, build is a physical system, right? Ultimately, it's a plant or it's a product. And what we think differently in terms of changing the representations of what we do, what we design in a much different way, so that tomorrow, AI algorithms can be applied on top of it. Because today, can we apply, let's say, algorithms on top of what we do, how we do? I would say no. Because we will need a lot of work in structuring the data, because every process, and I think Sunil described about a lot of use cases, and even Sanjay described about a lot of use cases where everything is unstructured. So I think that's where Technip Energies is putting a lot of efforts, both internally and for our clients. And just for everybody's information, so we have already, let's say, committed to our investors that through our digital acceleration, we will be saving, let's say, we'll have an annualized savings. And we have come up with a 4-year roadmap, which we are internally driving, not just for our operational efficiency, but also we are planning a lot of products for the customers. To talk about, so I was more talking about technical challenge, but then to talk about the other challenges, I think Hemo also mentioned about the cost, because that cannot be taken lightly, and that too in our industry. So cost, and also the skill sets, because today finding a person who knows engineering very well, and also the technologies, how to interlink with each other. For example, electrons to, let's say, the line of code inside the AI systems. So I think what, as an industry, as a let's say startup, and all the ecosystem, what we have to do is to concentrate more on building the models. Because once we do that, then we can bring a lot of value propositions in all the unstructured process that we talked about. Just for information, I was just fascinated by that, okay, with the traditional systems, with the traditional algorithms, 4 years back, I'm not talking about LLM era, 4 years back, they predicted protein folding. We are talking about 10 to the power of 300 combinations of protein sequences. Still, scientists did it using traditional neural networks, right? So all we are talking about here is not a computational problem. All we are talking about is not a, let's say, a problem from the perspective of economy and other stuff. It's more about, can we model those physical systems from the representation point of view? Can we define the parameters that really affect the system? Can we define the properties of the system? For example, properties make sense in our industry. And can we also define the environment that we are trying to understand? So I think once we build a good model of all this, then I think traditional systems can also bring a lot of results, which I think, again, like Sunil mentioned, which can be more reliable for the end customers.
Okay, you bring up a very important point around reliability, because I think when we talk about AI and algorithms, and especially LLM-based and Gen AI ones, it's more probabilistic. So how do we actually rely on the results that are coming from those? And that's where I think the data and the models need to be solid before we can use them. So thank you, Anandnambi, for that. Next, I'd like to come to you, Anson, because you are kind of at the intersection, I would say, of academia, startups, industry, bringing all of that together in an area like energy. And you have done some great stuff here at IIT Madras Research Park. But my question to you is, how do we actually kind of accelerate this lab to market journey? Because in academia, there's a lot of great work that's happening. But how do we actually accelerate, from TRL1 to TRL9, and then the commercialization and the scaling after that? So in your experience, what's worked well? And what can some of the entrepreneurs here think of as well? Can they work with the professors and the PhD students here to kind of commercialize faster? What are your thoughts?
Yeah, that's a great question, and something that we've spent a lot of time thinking. In that whole sort of journey from the lab to the market, we've sort of broadly categorized it under sort of 4 stages. The first one being, of course, the work that happens in the lab. And then you have the stage where you're sort of doing these early pilots. Then there's this important sort of third stage that we think is key in terms of early deployment. Some of the folks that can come in and test this out in a real world setting, and then finally the full scale commercialization. From our experience, I think each of these pieces need to be looked at separately, but also together at the same time. And one great example, and I think there's several, given the fact that we're an ecosystem that brings together these different stakeholders, is some of the work. I mean, maybe I can take an example of what we've done on energy. When we started off on this journey of moving this campus towards 100% renewable, we did sort of a mapping as to seeing what are our own gaps in terms of efficiency in particular. And we did this interesting project with Saint Cobain. They have their research centers here, where we simply did a heat gain mapping of this campus. And there was a very interesting insight in that the west-facing facade, or the block that is just next to the one that we're sitting in right now, was actually consuming 40% more energy. Everything else kept equal, simply because it is a west-facing facade. And that is shooting up my capex in terms of additional air conditioning requirement, as well as the ongoing OPEX that requires in terms of running these systems for decades, if not longer. And that simple insight just gave us a lot of ideas in terms of trying to demonstrate technologies that can solve for the problems that we identified in that particular stage. And so that was a great example of what we did together with an established organization like Saint Cobain. And then we looked at sort of developing technologies that could then further solve for some of the efficiency problems in terms of efficiency. So another just quick example is air conditioning large spaces. And I'm taking air conditioning particularly because 40% of my electricity bill, we consume around 1.5 gigawatt hour a month. So we're fairly energy intensive. 40% of that just goes in keeping us all cool and comfortable in this room. And so we sort of said, we're going to solve for that needle mover because that's just such a big chunk. And back to what I was trying to say, these large spaces, the cooling is very inefficient. Either you're actually feeling too cold or you're not getting any cooling at all. And so then we looked at deploying sort of sensors and systems that can effectively provide cooling in smaller spaces within a larger space based on occupancy and temperature in that particular zone. So suddenly you think of this large auditorium, split it into like 10 zones, and simply based on the occupancy in this particular zone and the temperature that we're sort of monitoring there, you're providing cooling as much as it's required. And that was solving for two things. One, it enhances our operational efficiency, and so you're saving carbon costs in that sense. And then there's the obvious problem that we have to be solving, that is thermal comfort. So I think these are sort of some examples through which we've found that, industry can come together along with, academia, that is from our side, along with the startups that we have incubated here to really solve for these problems in a very holistic manner. And so this is an entire exercise that we've taken up. And we're happy to share that, we've sort of seen the benefits of it from an occupant level all the way to sort of the building operations level, wherein we're not only saving costs for the companies that sort of occupy these spaces, but also sort of, making sure that all of us sitting here. In fact, this particular auditorium is the only exception to that solution that we'd built, unfortunately. And I'm openly admitting to it here because I've felt too cold or too warm in this very room. Unfortunately, we built this way before we started this exercise. And that's another problem. I mean, what do we do for spaces that are already built? I think there's certainly solutions that we can introduce and implement, but we have to sort of work together with both the industry and the many startups that I think are here to solve for these.
Thank you, Anson. And that was Anson, taking anticipatory bail, because I'm sure there were people in the room, saying I am too cold or I'm not getting any AC. So Anson did a good job of taking anticipatory bail there. But I think IITM Research Park has done a fantastic job of bringing all these different elements of the ecosystem together. So kudos to you, Anson and team. So Arun, I know that you said you perhaps don't have experience in energy per se, but what you're doing at Startup Singam is kind of evangelizing the startup ecosystem right from the grassroots level. So what I wanted to ask you is, because see, climate tech is perhaps not an easy area for startups to build in. It takes time. It takes a lot of patient capital. So how can startups in the climate tech space use a platform like Startup Singam? Especially because a lot of the climate tech startups are also B2B. So is there a bias that Startup Singam would be better for, say, B2C startups? Any specific advice to the founders out here for using a platform like yours?
Perfect. Thanks, Tina. So, what I see as a shift, right? So, from some early days, how disruption used to be a buzzword. If I look at pitches now, startup pitches now, efficiency is something which keeps coming more often, which itself is actually a very good sign. So, going to the startup ecosystem, earlier startup, it's a very difficult area to start in climate tech, exceptionally, especially before some time it was more, you were dependent a lot of the CSR funds from different organizations. There were very few funders for the same. But right now things are changing. Right now we are all sitting in this room. I see almost like around 1,000 people in around this place, which itself shows that there is a lot of interest and there are climate-focused funds. There are options. So Startup Singam, a platform like Startup Singam, what we do is, one, what we stand for, we bring in investors for a specific segment, we bring them together and we bring them to the startups, and where startups can explore funding opportunities. The second option is, it creates a lot of visibility. It creates a kind of visibility that will actually go ahead and help any startup grow. So early adoption is one of the things which is lacking, and that's a reason why if you look at the number of startups shutting down in the very early stages in climate tech is, I think it's pretty large in number. One of the reasons is there is no early adopters and there is nobody who's ready to fund at the early stages. Both those are kind of sorted now, and a platform like Startup Singam would actually create the right kind of visibility for startups to the entire ecosystem of buyers for you. I can proudly say that last year we had 2 startups which has been adopted, the services has been adopted by one large builder, and he has gone ahead and recommended the product to Credai, and many of the builders in Chennai are exploring the solution, and both are in energy saving space.
Oh, fantastic. So I think for the startups and founders out here, do consider a platform like Startup Singam, right? So it's not just about the funding, it's also about visibility and early adoption. So Narsi has definitely given me the boot. I think because I had such a great panel, I had to use their fantastic minds, right? So thank you so much for sparing your time and expertise, Arun, Dr. Arul, Anandnambi, Anson, and Sanjay. And thank you, audience, for staying patiently. I know it is, inching towards evening, and perhaps there are more exciting things happening outside the auditorium than inside. So thank you for being here, and thank you for being such a patient audience. Thank you.
Thank you everyone for your insightful session.